everybody doing? What's up, everybody? Oh, this morning I did a show on the solar system. What's up, everybody? And so, this morning I did a show on the solar system, and so this is a follow. Please, if you haven't, check out my webpage, check out my crowdfunding, become a Patreon, and then become a fan. I got a fan base club, and get on, click on that, and man, become a fan base. It's really awesome. So we're gonna jump right into this show, everybody.
The solar system is unique 20 to 30% of the time. In similar planetary constellations, the central star absorbs the planets that revolve around it. But if that's the case, why didn't this happen to us? The answer to this question may lie in the largest and oldest planet of the solar system, Jupiter. It is possible.
We are trying really hard to get you Reese's Peanut Butter Cups, but there is only so much we can do here. You're gonna have to meet us halfway. Well, the whole way, actually. We are trying really hard to get you Reese's Peanut Butter Cups, but there is only so much we can do here. You're gonna have to meet us halfway. Well, the whole way, actually.
It's possible that before Earth, Venus, and Mercury, there have been other planets. However, they may have been destroyed by Jupiter, laying the foundation for the current solar system. In fact, what if we told you that Jupiter might have originated outside of our star system? Today we'll talk about the hypothetical migration of the gas giant, as well as the way this may have affected life on Earth. As you know, Jupiter is a huge planet composed entirely of gas, mostly helium and hydrogen. The first studies of Jupiter took place back in the 17th century. However, many aspects in regards to this planet remain unsolved to this day. For example, Jupiter's most notable feature, the Great Red Spot, or GRS, is still controversial in scientific circles when it comes to its origin, length of existence, and color. Jupiter's rapid rotation around its axis, approximately 9 Earth hours, creates lengthy and powerful cyclones and anticyclones that can reach speeds of 335 miles per hour. The Great Red Spot is an anticyclone that has been around for over 300 years. However, the GRS is decreasing. According to NASA, in the 19th century, the size of the anticyclone was estimated to be 25,500 miles in width. But now it is slightly larger than the diameter of Earth, 10,250 miles. The reason for the size decrease of the GRS is still unclear. But NASA scientists suggest that the answer may be some unknown activity in Jupiter's atmosphere, which weakens the wind currents. Another mystery of the GRS is the signature red hue. NASA scientists suggest that the cause of the redness is a little-known colorless gas, ammonium hydrosulfide, and it forms sulfur when exposed to solar UV. What's more, NASA scientist Amy Simon believes that there's a correlation between the intensity of the storm's color and its speed. According to her research, the color of the GRS becomes more saturated when the wind speeds up. In addition to helium and hydrogen, Jupiter's atmosphere contains heavy elements such as nitrogen, argon, xenon, etc. However, these elements could only form at very low temperatures where they mixed with other elements that occur in hot environments. This led scientists to the conclusion that perhaps Jupiter did not originate in the same place that it now occupies in the solar system. This gas giant could have theoretically formed 4 times farther away from the Sun. Jupiter might have been enriched with heavy elements and then headed towards our star, completing its formation. To understand the possible migration of Jupiter, let's take a closer look at how gas giants are formed. Gas giants form in a similar way to ordinary planets, but with a few differences. After a star is born from gas and dust clouds, the excess material rotates around the star, kind of like giant planetary rings. These rings are known as the protoplanetary disk. This is what the planets are formed from. On average, a protoplanetary disk only exists for a very short time on a cosmic scale, up to 10 million years. The disk consists of 99% gas and only 1% dust. As the dust particles crash into each other, thanks to gas, they stick together and form larger objects known as planetesimals. As they continue to gain mass, planetesimals
What the fuck? What?
eventually become planets, asteroids, or moons, depending on the amount of material. Planets with a solid surface are formed closer to the star. This is due to the fact that the radiation released after the birth of the star, it can't push heavy elements that make up the planets, like the stone and metal, very far. Gas giants form away from the star as radiation can push the gas farther away. However, a lot of gas is not enough to become a gas giant. These planets must also have a massive solid core to attract gas. So how do the gas giants form such large nuclei if the building materials do not reach them in the quantities they need? According to the research of astrophysicists Kobayashi and Tanaka, these giants can build up large core mass thanks to pebbles that are pulled into the solar system due to the orbit of Neptune. Additionally, the ice particles that are pushed out by radiation as vapors can act as a building material for the core. Finally, it is possible for gas giants to be born outside the planetary system and then migrate into narrow orbits. The hypothesis of such planetary migration is called the Grand Tack hypothesis. The Grand Tack hypothesis by Kevin Walsh of the Southwest Research Institute in Boulder suggests that Jupiter likely originated much farther away from the Sun than its current position and gained its mass as it migrated toward the Sun. Also, this hypothesis suggests the migration of Jupiter may have caused the emergence of the asteroid belt and even the insufficient mass of Mars. According to a study by a team of astronomers at Lund University, the future gas giant may have potentially originated in the outer region of the solar system as an icy asteroid. After 2 to 3 million years, Jupiter likely accumulated a mass almost equal to our planet and began to shift towards the Sun. Researcher Sho Shibata explained that Jupiter may have been about 20 AU from the Sun when the solar system was first formed. Affected by gravity, the gas giant headed towards the Sun. On its journey towards the Sun, Jupiter likely chose a very successful path, which was filled with the material necessary for its development. The streams of gas that were still orbiting the newborn Sun were most likely picked up by Jupiter. The gas giant went in a spiral and took a total of about 700,000 years. Hypothetically, Jupiter may not have been in the same place where it is now. The gas giant potentially occupied the current place of Mars. Over time, Jupiter must have migrated to the new space it now occupies in the solar system. A likely proof of Walsh's hypothesis is a group of asteroids called Jupiter Trojans. These asteroids surround the planet from two sides, the front and the back. While exploring these mysterious asteroids, scientists have been very puzzled as to why the group of Trojans in front of Jupiter is twice as large as the one behind. Thanks to computer simulations, scientists at the University of Lund in Sweden have concluded this is a symmetry and is probably caused by planetary migration.
I've been telling all of you for months to claim this free $6,400. Anyone can get this, even if you don't have a job. But now, this is the last week you can apply for it. This is due to a state-released subsidy for all Americans to get back on their feet by receiving free funding every month. You just can't be on Medicare or Medicaid, and you qualify. They send you this $6,400 in health credits on a health spending card that you can use to cover all your daily bills, needs, and expenses. You'll always have so much cash left over to pay for rent and groceries. You'll be able to quit your second job because these cards receive health credits every single month. I put the link below where anyone can claim this for themselves. It takes only one phone call. Just click it, answer 2 questions, and get on a call with an agent.
Based on that hypothesis, during the internal migration, Jupiter's gravity widened the particle path, securing more Trojans in front of it. Scientists suggest that the Jupiter Trojans may have been part of the Kuiper Belt, which is located beyond the orbit of Neptune. These asteroids have the potential to allow scientists to explore materials left over after the birth of the solar system without sending spaceships that far. Naturally, the significant space maneuvers of a giant planet could not have left our solar system unaffected. The most compelling evidence of the grand tack is Mars. It's possible that without the intervention of Jupiter, the red planet would have been larger than Earth. Mars was formed around the same time as Jupiter, so it had the time and opportunity to accumulate a significant mass. However, Mars is only about 4,225 miles in diameter, and for reference, the diameter of the Earth is 7,955 miles. So Mars is about half the size of our home planet. Jupiter is most likely to blame for this. When the gas giant got close to the Sun, it may have absorbed or dispersed the materials that were intended for Mars towards Earth and Venus. Jupiter's mischief doesn't end there. There is an asteroid belt between the orbits of Mars and Jupiter. It covers approximately 140 million miles. The belt mainly consists of small asteroids, although it also contains several larger bodies. For example, there's a dwarf planet, Ceres, as well as large asteroids up to 400 miles across, including Vesta, Pallas, and Hygiea. It is possible that another planet could have formed from this belt. However, according to the grand tack hypothesis, its formation may have been prevented by the gravitational forces of Jupiter. Because of the gas giant, the planetesimals were not able to unite and simply fell apart. It's possible that Jupiter may have also dispersed a significant amount of materials in the process of migration. Therefore, even if it were possible to switch off the influence of Jupiter, the mass of the belt would not be sufficient to form even a small planet similar to Mars. Finally, the least apparent but most significant consequence of Jupiter's migration was the likely destruction of the first planets in our system. The solar system is really different from other systems. Many of the known planetary systems similar to ours have super-Earths in their composition. These planets are larger than Earth and consist of either rock or gas or a combination of both. So why don't we have planets like that in our system? Astronomer Konstantin Batygin suggests that such planets may have existed in the early days of the solar system. However, it's possible that Jupiter destroyed the first generation of planets. The gravitational influence of Jupiter, which hypothetically traveled close to the Sun and then back to current orbit where it is now, led to the collision of the forming planets. In fact, Jupiter may have set the stage for the formation of the planets we know and, of course, the planet we live on. However, the formation of planets takes a very long time from humanity's point of view, several million years. Therefore, Mercury, Venus, and Earth continued to develop from an already slightly depleted protoplanetary disk. Delayed formation explains the small size and thin atmosphere, as well as the age difference between the outer and inner planets. Admittedly, it is possible that it was Jupiter that influenced the current structure of the solar system. The annihilation of the first planets and the obstruction of the development of Mars may sound like negative events. However, Jupiter's intervention may have had positive consequences for us. What if we told you that the gas giant's migration probably gave the opportunity for life to evolve on our planet? The mystery of the huge amount of water present on Earth is still unsolved in the scientific community. The oceans could not have come into being at the same time as our planet, since all water would have evaporated due to the very high temperature during Earth's formation. However, water probably existed inside our planet, but there was not enough of it to cover 70% of the Earth's surface. The small asteroids are considered to be the most likely source of water, having contained water in the form of ice. Over the course of its migration, Jupiter may have sent these asteroids in our direction. Moreover, according to astronomer Phil Plait, in addition to water, meteorites containing building blocks for living organisms, that's small asteroids that reach Earth, such as amino acids from which proteins are formed. Therefore, Jupiter may have been one of the reasons for the origin of life on Earth. In a way, Jupiter can even be considered our shield to some extent. The gravity of the gas giant can change trajectories of dangerous asteroids and comets, steering them away from Earth. And furthermore, Jupiter is capable of absorbing comets that have the potential to become a threat to other planets. For example, in 1994, the 1.2-mile comet Shoemaker-Levy 9 crashed into Jupiter. If this had reached Earth, all life on our planet would have been doomed. However, in order for water to exist on Earth as abundantly as it does now, Jupiter most likely sent asteroids in our direction. That is, Jupiter does not always protect us. On the contrary, it can also be a source of attack. Professor Jonte Horner of the University of Southern Queensland has determined that Jupiter increases the risk of asteroids colliding with our planet. Nevertheless, if Jupiter had a smaller mass, it would have dramatically increased the possibility of cosmic bodies reaching Earth. Therefore, Jupiter definitely plays an important part in our life, but it also has the potential to harm it. Interestingly, there's another subtle influence that Jupiter has on Earth. The Earth's orbit is almost perfectly circular. However, due to Jupiter's gravitational pull, it can stretch into an elliptical shape. This deformation of the orbit will lead to significant climate changes. The summers become much hotter and the winters much colder. Of course, this does not happen very often, only every 405,000 years. But we're currently in the midst of that cycle. The migration of Jupiter has not yet been confirmed and requires further research. However, it's likely that without the gas giant, our solar system would be completely different. It is possible that without its influence, life on Earth may not have existed at all. In 2021, NASA sent the Lucy spacecraft to explore the Trojan asteroids. Perhaps its expedition will reveal more data to confirm the hypothesis of Jupiter's migration, and may also allow us to study the material from which our universe was formed more than 4 billion years ago.
I just saw this on TV. We can claim up to $1,400 in benefits now every single month until at least 2025. Check it out. The government is basically giving me $1,300 in premium credits every single month just because I'm under 65 and make less than $50K per year. Everyone with a social security number can qualify to get up to $1,400 in benefits by the United States government. It is set aside under this new act that just passed. Guys, it's powerful. You have up to $1,400 in benefits that's already there waiting for you. You just have to unlock it. The link to the page I used is below this video. Click the button now to claim yours. Since telling people about this, I have had such an overwhelming response. So I know that people really need the benefits. If you're seeing this video, then your state is one of the approved states that is eligible for these premium credits. It's seriously not even hard. All you have to do is do what I did. Go to this link below and tell them you are under 65 and make less than $50K per year, and that you are not on Medicaid. And then a few minutes later, they'll tell you exactly how much you can qualify for and how soon you can get it. Just imagine receiving that kind of assistance every single month. It's life-changing. Now, I am getting my credits every single month like clockwork. And I haven't paid a cent for any healthcare costs. And the amount I'm saving is crazy. It's even covering all of my groceries, gas, and even some of my rent. You can use these benefits and services included in the package every month at stores and pharmacies like Walmart, Target, and CVS, and many others that participate in the program. But sadly, you only have until the end of this week to call and claim this benefit. Remember, the link to the page I used is below this video. Click it now to claim yours. I really don't know why they are giving this much out, but every American family needs to see this. They said the deadline to qualify is this week, so if you want to see what you can qualify for, make sure you hit the link I left for you below this video now, because you might not see this again. Like I said, I've literally paid nothing out of pocket for any of my essential health and medical-related costs, because it's all covered by this program, and yet it still seems like no one is even talking about it. I don't know how every family in America hasn't heard of this yet. I just wish I signed up sooner because, unfortunately, you only get these benefits if you call and sign up. So every day, week, or month you put it off could mean you miss out on thousands. Again, the link to the page I used is below this video. Click the button now to claim yours. I've been telling everyone I know about this. As an example, my friend Rick has been pretty broke since graduating college. He was taken off his parents' insurance and left with all his medical bills. I sat with him and forced him to check out this link, and he got signed up in like 3 minutes. And it's saving him something like $330 every single week now. Because of the savings, he was finally able to go get a new car. Now that he doesn't have to walk, he even got a better job. Now, Rick is no longer broke, and no longer has to pay for all of his medical expenses. It was really a life-changing moment. Okay, I'll leave you to it. If you want a life-changing moment like Rick had, go ahead and hit that button below. And find out what you can qualify for right now. Hurry before the deadline rolls around.
If you have an hour this week, you can learn 100 songs on the piano by learning just 4 chords. These. Check it out.
And can you feel the love tonight?
Same chords.
When I find myself in times of trouble, Mother Mary comes to me. Sometimes I feel like I don't have a partner.
Exact same chords.
No woman, no cry.
Again, same chords.
The deeper we dive be amazing to just switch off the lights? I live in a city, and that means the stars are hard to see, and the universe is easy to forget about. Our busy lives and streetlights hide away so much wonder. Wouldn't it be amazing to just switch off the lights and connect with a world beyond our own? That's what I want these videos to be. Little escapes into the universe that we can all go on, regardless of whether we have clear skies, telescopes, or lots of free time. We're going to go on a journey into the starry sky above me, a world we can all connect with. But this is not a video about the universe, because this isn't the universe. Not really. Let me show you what I mean. I'm going to leave the universe alone, but I'm going to switch one thing off. So that's it. The stars have all gone. I can only see one star in the night sky now. And really, it just looks like a big faint smudge. It's actually the Andromeda Galaxy, but otherwise, it's just blackness. All of the magic of the night has gone. Imagine a world without stars. The thing I switched off wasn't the universe, it was the Milky Way, the galaxy we live in. Okay, phew, it's always good when they come back. So our night sky is actually our galaxy, the Milky Way. Our galaxy is our home, a huge swirling oasis of stars. It's so big and full of everything, it's like a mini universe all on its own. Our sun and solar system is about here, a third to a halfway out from the center, depending on how you measure where the edge is. Some people point to the cloudy line across the night sky on a really clear night and call that the Milky Way. And technically it is, but then so is everything else as well. So it's a little confusing. I think a better way to describe that is the disk of the Milky Way, and we're inside that disk. If I make the Milky Way 2 football pitches wide here and tilt it a little, then shuffle it back so it's where we are in the galaxy. If you take a look from my point of view, I'm going to walk to where the Earth is. When I look towards the center of the Milky Way, I can see this cloudy line that stretches across. When I look to the sides, I'm looking away from the galaxy, so there are fewer stars. So that's what that line is in the sky, the edge of the galaxy that we're inside. And that line is brightest looking towards the center of the galaxy. But look, there's no point in looking at a model of the Milky Way this big. It's not big enough to see the detail. I need to make it bigger. I'm going to need to make it the diameter of the United States of America. If the center of our galaxy were in Kansas, right in the middle, the solar system would be about here, in the city of Denver in Colorado. In fact, all of the stars that we can see in the night sky would only stretch as far as the city lights of Denver. So how big would we be? How big is the sun on this huge scale? Well, on a scale where the galaxy we live in is the diameter of America, the sun would be about this big. So that's already completely crazy, but it doesn't end there. Because I'm not standing on a hill here. On a scale where the Milky Way is the size of the United States, our giant sun would easily fit between the ridges of the fingerprint on the tips of our fingers. It would be half the size of a red blood cell. Our galaxy is astonishingly large. I've shrunk myself down 50,000 times to be this size. This is a single grain of sand in comparison. It's taken me 2 minutes to walk over to where Earth is, here, one fingerprint ridge away. Here's our little blue marble. On this scale, it's 3 times smaller than the coronavirus. Jupiter here was 4 more ridges away. Neptune, the last planet, has taken me an hour to walk to. It's just 1 centimeter away at the edge of my fingertip. Isn't it crazy, but wonderful?
that if our galaxy were shrunk down to the size of a continent, the orbits of the planets of the solar system would be the swirls on the tip of our finger. We're always interested in how big the universe is, but the galaxy we live in, the Milky Way, is so wonderfully vast and impressive. Now, I know the Milky Way alone is so much to take in. It's natural that it can all seem overwhelming. It can also make us feel a little small and insignificant. And we are a little small, but we are also special. Humans are incredibly complex life. We are the first beings we know of with a curiosity and ability to find truth and wonder. That makes you just as important as a galaxy. In the words of one of my favorite wonders of the universe, Carl Sagan, we are a way for the universe to know itself. And if the galaxy still feels overwhelming, this might help. We are small, but we're probably a lot bigger than you think. We tend to put ourselves at the bottom of the scale, but that ignores the universe under our noses. The world of the small is as vast as the stars, and that is an accurate statement. This is an electron. It is very small. I've made it bigger here, obviously. It's part of an atom. It's so small it's considered a point, not a sphere. So this is just a crude model of a kind of maximum size of an electron. With that in mind, in terms of scale, an electron is to a human what a human is to the Milky Way. So if you ever feel lost or small when you contemplate the cosmos, just remember that to an electron, you are a galaxy.
What's that awesome point?
If you enjoyed the videos on my epic
Would you believe that doing a simple 5-minute trick just once a day can raise your credit scores into the 700s and even...
The Milky Way is a tremendous structure in space containing billions of stars and trillions of planets. In their turn, these objects are surrounded by gigantic clouds of interstellar dust and scorching hot gas streams. All these components make up the bizarre and fascinating picture called galaxy. And today, we invite you on an exciting journey across it. We'll start out near the star system closest to our Sun, Alpha Centauri. Whizzing on hundreds of times faster than light, we'll fly around some of the most remarkable stars closest to us, and then briefly stop near an unusual planet whose surface is completely submerged by a perpetually boiling ocean. Placing our lives in peril, we will nevertheless approach an unstable pulsating giant enjoying its last millennia of life, and then pay a visit to the most extreme and forbidding exoplanets. Straight after that, it will be time for the most mysterious and dangerous objects in the Milky Way, black holes. And then we will pierce the galaxy in a swift flight, from the bright center richly illumined by the stars to its very edge, concealing mysterious dark matter. Let's get ready, and we begin.
Cosmo.
The first outer space. The Earth has been emitting structured radio signals into space for around 100 years now. The radio noise from the Earth reached dozens of other stellar systems long ago, including Arcturus, lying 37 light-years away from us, and Aldebaran, which is roughly 65 light-years away. Besides, our radio signals may be heard on the surfaces of a great number of potentially habitable exoplanets, like Ross 128b or Gliese 667cc. Still, the triple stellar system of Alpha Centauri remains the closest neighbor of the Sun, which automatically makes it the first obvious candidate for the destination of the first ever interstellar flight. Alpha Centauri is known to be a multiple stellar system made up of 3 components. 2 of the larger ones are relatively close to each other. Seen with the naked eye, they appear to be a single source of light. The 2 components follow a slightly elongated orbit around the common mass center, which takes around 80 years to complete. The maximal distance between the stars may reach 35 astronomical units, with the minimal distance reaching 11.2 astronomical units. As for the distance between these objects and the Sun, it is reportedly 4.36 light-years. The most massive, the largest, and the brightest component in the system is dubbed Alpha Centauri A. This is a main sequence star with a mass of about 108% that of the Sun. Its radius is reportedly 1.22 times that of our Sun. Even though the surface temperature and the spectral class of Alpha Centauri A are close to those of our star, it emits 1.5 times as much energy. There are no confirmed exoplanets in the environs of this star. However, while the star was being observed in the infrared in 2021, some evidence was found of there being a planet-like object close by. According to preliminary estimates, its mass may be anything from 9 to 35 Earth masses, and its radius may measure 3.3 to 7 times that of our planet. 1.1 astronomical units away from its parent star, the hypothetical celestial body completes a full orbit around it within roughly a year. Additional observations are called for to verify the data, which can be done with the help of either the James Webb Telescope or else Earth-based observatories. The second component of the system is called Alpha Centauri b, or Ptolemy, and it also falls into the class of main sequence stars. However, its mass is 10% less than that of the Sun, and its radius measures only 86% or so that of the Sun. Ptolemy is also slightly cooler than our star. Its surface temperature is reportedly 5,260 Kelvin, or slightly lower than 5,000 degrees Celsius. With these factors combined, the celestial object has an orange hue, and its luminosity is on average twice as low as that of our Sun. Incidentally, Alpha Centauri b emits a lot more energy in the X-ray range compared with other objects of its class. Besides, the star is peculiar for its temper, and there are bright flares and ejections to be seen on its surface. No confirmed exoplanets have been detected near this star either. In 2012, a group of astronomers from the Geneva Observatory put forward a suggestion that there was a planet very close to it, whose orbital period was around 12 days, and whose radius measured slightly less than that of the Earth. The suggestion was made based on 4 years of observation of the star's proper motion. However, 3 years later, a mathematical error was detected to have been made in the course of data processing, and so the idea of there being a planet was found to be erroneous. The third component of the system is a stark contrast to the first two. It is a red dwarf with a mass approximately 12% that of the Sun. Its size is about 7 times smaller than that of the Sun. Its surface temperature is only slightly higher than 3000 Kelvin, and its luminosity is just a measly 0.17% that of the Sun. Of all the components of the Alpha Centauri system, it is this dim space object that is the closest one to the Sun, lying 4.25 light-years away from it. This is what earned it its name, Proxima Centauri, which is Latin for closest. Besides, the object is getting nearer and nearer. Thus, in 26,700 years, it will be only a bit more than 3 light-years away. Still, this star cannot be seen from the Earth on account of its low luminosity. Proxima is noticeably far from its two companions in the stellar system. This distance is currently around 13,000 astronomical units, or 0.21 light years, but in the next 300,000 years, it is expected to gradually shrink to just 4,100 astronomical units. It takes Proxima 547,000 years to orbit around the system's common mass center. Unlike its two larger neighbors, the Proxima Centauri system boasts two confirmed exoplanets, as well as at least one hypothetical object. Besides, studies of the star in the infrared allowed scientists to assume that there is a dust ring and probably a great number of small celestial objects, like asteroids or comets. The first planet in the system, Proxima Centauri b, was detected in 2016 by the radial velocities method. 4 years later, in 2020, it was confirmed by spectrographic studies with the help of the largest Earth-based telescope on our planet, VLT, the Very Large Telescope. According to the updates, the exoplanet lies 0.05 astronomical units away from its parent star, and it takes it roughly 11 Earth days to complete a full orbit. Estimates show that the planet's mass is 10 to 20% bigger than that of the Earth, and its radius measures about 1.3 times that of our planet. Mathematical modeling revealed that Proxima Centauri b gets about 1.5 times as little thermal energy from its star as does the Earth from the Sun. Its average temperature is 234 Kelvin, or 39 degrees Celsius below zero, which means that hypothetically there could be liquid water in some areas on the planet. As the celestial body is extremely close to its host star, however, it is likely to be tidally locked, so it faces the star with one and the same side. A dense atmosphere could compensate for sharp contrasts in temperatures, which are inevitable in such conditions, but just like any other red dwarfs, Proxima Centauri is often seen to eject stellar matter. Also, iron